Hello, my name is Dustin Norton, and in this video I will be describing the fate of lactate, which is the lactate pathways between the liver and the muscles. Also in this video, we'll be describing how exercise intensity affects lactate and any training adaptations it might require, as well as if lactate can be used metabolically, what consequences it might have. Let's get started. Here's a diagram of the quarry cycle, which is the metabolic pathway in which lactate produced by anaerobic glycolysis in the muscles moves to the liver and is converted to glucose, which then returns to the muscles and is metabolized back to lactate. During muscular activity, ATP stores need to constantly be replenished. When the supply of oxygen is sufficient, this energy comes from feeding pyruvate into the citric acid cycle. But when oxygen supply is insufficient, typically during intense muscular activity, energy must be released through anaerobic metabolism. Lactic acid fermentation converts pyruvate to lactate by lactate dehydrogenase. Most importantly, fermentation regenerates NAD+, maintaining the NAD+ concentration so that additional glycolysis reactions can occur. The fermentation step oxidizes the NADH produced by glycolysis back to NAD+, transferring 2 electrons from NADH to reduce pyruvate into lactate. Instead of lactate building up in the muscle cells, anaerobic fermentation is taken up by the liver. This initiates the other half of the quarry cycle. In the liver, gluconeogenesis occurs, which reverses both glycolysis and fermentation by converting lactate first into pyruvate and then finally back to glucose. The glucose is then applied to the muscles through the bloodstream. It is ready to be fed through further glycolytic reactions, and if the muscle activity has stopped, the glucose is used to replenish the supplies of glycogen through glycogenesis. The quarry cycle, -4 ATP molecules, because glycolysis creates 2 ATP and glyconeogenesis uses 6. Now we will discuss exercise intensity and training adaptations. According to Baker, McCormick, and Roberg, lactate metabolism is integral for sustaining a high rate of glycolysis during exercise, and without it, high-intensity exercise would not be possible for more than 10 to 15 seconds. Armstrong says it can therefore be noted that sprint athletes, particularly those who run for more than 10 seconds, such as 400-meter sprinters, are more prone to lactate accumulation than marathon runners. Many researchers believe that the fatigue resulting from intense exercise is due to the hydrogen ions and not lactate anions. According to Hargraves and his colleagues, there is, however, a clear association between the production of lactate and muscular fatigue. Some studies indicate that a decline in exercise performance with repeated sessions may be due to the decline in the availability of creatine phosphate, decrease in sarcoplasmic reticulum function, increase in hydrogen ions, and other factors that induce fatigue, but not a decrease in glycogen. Gladen states, due to the negative factors earlier associated with the production of lactate, for most of the 20th century, it was believed that lactate had no metabolic use and was merely a waste product of glycolysis. Evidence, however, supports lactate as a fuel source for anaerobic energy metabolism as well as an intermediate in the repair of wounds and regeneration. He further goes on to explain that muscles are now considered a consumer of lactate. The rate at which lactate is used is dependent on the rate of metabolism, blood flow, lactate concentration, hydrogen ion concentration, fiber type, and exercise training. Lactate is an aerobic um, metabolite when glucose or glycogen is the fuel source and adequate oxygen is available. When there's increased availability of lactate during intense exercise, it can be used as an alternative fuel source for the heart, decreasing the need for glucose. As Passarella states, and as exercise increases, lactate becomes a preferred fuel for cardiac muscles, which is where it is oxidized to CO2 in the myocardium, the heart tissue. And in skeletal muscles as well, the energy demands can be high as such, um, and there is a high rate of glycolysis, making it a heavy producer of lactate. Lactate, however, can be taken up by both the skeletal muscles and the heart, which then uses it as a respiratory fuel to satisfy increased demand for energy. In conclusion, it seems that lactate has a lot of great functions in the body. As research continues to progress, there needs more research in um, its its effect on fatigue, and furthermore, the use of it, how the body uses it in different places. I thought it was very interesting that um, the heart uses it so much when there are high intensity exercise that it takes. Thank you. Have a good day. Following is my references.